everybody. All right, let's get started with our introduction to transformations and isometry. Let's start by filling in some blanks here. First one, an isometry. Is a movement of a geometric figure. So you're going to take a shape, figure, and move it. And when we move it, we're still going to keep the size. So the size is going to stay the same. So that keeps the size and shape of the figure the same. Not changing the size or the shape, we're just going to move it. Okay, so there are three types of isometries. The first one is called a translation. And some words that I use to remember translation are slide or shift. So we're just going to take a geometric figure and we're going to slide it left, right, up, down, or diagonally, or shift it, but not change the size of it or the shape. Okay, the second type of isometry is called a reflection. And some words, or a word that I use to help remember reflection is flip. So this arrow is pointing up, we flipped it over this line right here, and that is a reflection. Okay, the third one is called a rotation. And a word that I use to remember rotation is turn. So again, we're not changing the size, we're not changing the shape, we're just taking that figure and we're turning it. Okay. The next thing, a dilation is another term that keeps the shape the same, but it has the shape get bigger or smaller. Would not be considered an isometry. Okay. So in all isometries, in the translations, in the reflections, and in the rotations, the first shape is called the pre-image. And the second shape is called the image. Okay, so the first one's the pre-image, the second one is the image. So let's do some examples, keeping those terms in mind. Okay, so using the graph of this transformation, we have A, B, C, D, E. So this green geometric shape on the in the first quadrant, that is the pre-image. Okay, so here it says figure A, B, C, D, E. Okay, if that's the pre-image, what then does that line up with? What does that map onto for the image? It would be figure, okay, so you start with A. So if here is A, then that is going to line up or map to X in the image. So figure X. And then the B is going to line up with W. C is going to line up with V. D goes with Z. And E goes with Y. Okay, so name and describe the transformation. This would be a reflection. And it's reflecting over this axis right here, the y-axis. Okay, now we're going to see what angles, what sides from the pre-image map up to the image. So for letter C, name the angle that corresponds to angle E. Okay, so you have angle E in the pre-image. What angle is that going to correspond to in the image? That would be angle Y. Okay, name the image of CD. So you have segment CD. That is going to line up with segment VZ. Okay, we can also go the other way. They're going to give us a segment on the image, and we need to name that corresponding segment on the pre-image. So name the pre-image of YZ. So YZ, that's going to line up with ED. Okay, F, name the coordinates of the image of point B. Well, the image of point B is going to be point W, but they want us to actually give the coordinate points. So that would be -1, 1 to the left, and then up 4. So -1, 4. And then lastly, name the coordinates of the pre-image of point V. Well, that is going to be point C. And the coordinates of that would be 4, 2. Okay, next example. Find the value of each variable given that the transformation is an isometry. Okay, so size and shape are not changing, but you can tell from the arrow that it's rotating. And also here it's telling the pre-image which angles and sides correspond to those on the image. So if we even start off and you say, okay, so G here corresponds to B. So right here, angle G is going to correspond to angle B. So that means we can take angle G, which is Z plus 12. That has to equal angle B, which is 2Z minus 8. Okay, so then to solve for this, if we subtract Z from both sides, we'd have 12 here equals Z minus 8. Then add 8 to both sides, and you would get 20 equals Z. So that's one of the variables that we were asked to solve for. Okay, then now let's look at the ones that are segments here, sides. Alright, so we've got GR, this side right here. So GR lines up with BQ. Alright, so over here. So then we can say x minus 4 equals 23. And then if you add 4 to both sides, x equals 27. Okay, and then the last one, well, we've got side RM right here. And if you look at the mapping here, RM corresponds to QY. Okay, so we can say then that 3y minus 7 equals 2y plus 5. Okay, we can subtract the 2y over, so we would have y minus 7 equals 5, and then add 7 to both sides, which gives us y equals 12. All right, good job.